Welcome to Module 203E on Basic Hot Water Heating Systems. These types of heating systems are just a different way of heating buildings, and it's an alternative to forced air furnaces. This module has two different objectives. The first one is to describe the operation of a basic hot water heating system, and then we're going to look at the purpose and the application of the components within that system as well. Hot water or hydronic heating systems are very effective for large buildings and hard to heat areas. They utilize a boiler that heats either water or glycol water mixed instead of the air, and then the heated water is then circulated and the heat will be radiated into the space. Once the water or the glycol mixture is heated by the boiler, it is then circulated throughout the building using either one pump or multiple pumps. If we utilize multiple pumps, we can separate them into zones, and that allows us to have better control over how much heat is in each area. The setup can vary depending on what the building requires. Once the heated water is pumped into the different spaces, we require a heat exchanger in order to get that heat from the water and into the space. Heat exchangers can be multiple of different styles, including radiators, baseboard units, unit heaters, plenum-mounted heat exchangers, and radiant panels or in-floor heating. Radiant panel zone heating is one of the most common types of hydronic heating that we do see on the job site. The panels are made up of pipes inside the floor, usually concrete, and we refer to this as in-floor heating. The concrete floor itself then becomes a heat exchanger and radiates the heat from the concrete into the air. Radiant panel systems are typically used to heat basements, garages, sidewalks, and driveways. This type of system can be zoned so that we can control areas separately. A zone would be a dedicated set of pipes going from the boiler unit through a room or an area and then returning to the boiler unit. And the zones are controlled in one of three different ways. We can have one pump per zone, and that pump is controlled by a thermostat independently, or we can also have one pump per zone and then also have a main pump to assist in the circulation of the water. This type of system is very useful in taller buildings where we have to go up multiple floors. The main pump builds up what is called head pressure. So all the piping from the main pump to the zone pumps would maintain a certain amount of pressure, and then when the zone calls for heat, the zone pump would turn on and it would circulate the water through that area. The next type that we have would utilize a main pump and zone valves. This is something that we typically see a lot of in residential, where we reduce our costs by only having one pump, and then instead of having a pump per area, we simply have a valve to open and close whenever the thermostat calls for heat. Here is an example of a completed system with individual zone pumps installed. The upper manifold is for the supply of heated water to the zone pumps, and the lower manifold is cooled water for return to the boiler. This is also called a closed system. The water that is circulated for the space heat is completely separate from other water inside the building. The water glycol mixtures are used in areas where freezing might be an issue, since glycol is an antifreeze. So most commonly in Canada, we would see a glycol mixture inside the pipes rather than a straight water mixture. Typically, mechanical contractors will install the system. However, we are responsible for taking care of any of the supply and the control wiring. Our supply wiring will fall underneath the scope of Rule 26800. We need to pay attention to Rule 26808 that states that we must have a dedicated circuit with the disconnect, and that disconnect must be within sight. And we can follow the same rules that we have for furnace, where we can use a breaker if the breaker is between the point of entrance and the system. Another rule we need to be aware of is that any conductors under 1.5 meters do require mechanical protection. Our control wiring is supplied from an integral Class 2 transformer. Therefore, Section 16 in our codebook applies. The transformer is supplied from the manufacturer, and it is sized to handle all the low voltage components. This is reference to the VA rating of the transformer. We need to make sure that we follow manufacturer specs in order to avoid any overloading in case new components are being added to the system. All of the controls are optimized by using a digital control system. Within the digital control system, all the thermostats, the valves, the pumps, and any sensors will go back to a central unit. This will increase the energy efficiency and provide for more heating control. This utilizes variable speed injection pumps for precise temperature control, actuating motors or modulating gas valves, digital controls that monitor the outside air temperature, and that is also being used for demand prediction. You have now reached the end of this objective. Review your module, complete the knowledge check, and then continue on to the next video.